right, so reflections. Reflections are figures that are either flipped or appear to be mirror imaged with a line of reflection, or a line that would have been folded if you were going to flip something, or do like a symmetrical comparison. So let's see, for example, let's draw a line of reflection. And if you have a figure here, let's assume that I made this with wet ink and the ink is still wet. And if I were to fold it on that black line that I just made, and then I open it back up, that ink will stick and create an image on this side, identical to the opposite side, just mirror imaged. So that would be an example of a reflection. Or let's say you have a reflection over this horizontal line. Say I have this figure here. And again, if this was drawn with wet ink and I were to fold it over this line of reflection, pick it back up, the ink would look like it's stuck on this side, creating a mirror image. So you could think of it as being in the mirror, think of it as a wet ink being folded over that line and how it would look on the other side. So that's how you would know that you would definitely have a reflection. And sometimes you have to physically do that in order to see it. So we'll do that later. So a reflection by definition is a transformation in which a figure flips over the line of reflection creating a mirror image of the original figure. Okay, so transformation in which a figure flips over the line of reflection, creating a mirror image of the original figure. So these are considered mirror images. So just to get some rules out of the way before we go ahead and start some examples. And so let's go over some rules of reflections. All right, so we understand that a reflection looks like it's been flipped over. And there's two ways that that happens, over the x-axis or over the y-axis. So when you're doing reflections, over the x-axis would mean that it's jumping from positive down to negative, or vice versa. It could be from negative up to the positive. So it doesn't really matter where it's originating from as long as it's flipping over the x-axis. So over the x-axis means this is a vertical change. Your figure is going from top to bottom. That is in the direction of the y-coordinate. So the y-coordinate is the one that's going to be changing. Your x-coordinate is not going to change, but your y-coordinate is going to become its opposite. So whatever y is, you're going to take the opposite of y. So for example, if you have a positive 2 here, it'll be a negative 2. If you have a negative 2 down here and it reflects up, it'll become a positive 2. So that's how it works. By the way, opposites. What exactly do opposites mean? How do you know two numbers are opposites? Just because one has a negative and the other one doesn't? That's not really the mathematical definition. Opposites are any two numbers that are the same distance from 0. So notice that the distance that you have from the reflection line up will be the same distance you have from the reflection line down. So these two numbers turn out to be opposites because of that. And the distance you have from the reflection line up and the distance down will be the same. Therefore, you can confirm that they will be opposites. And so now let's see what it looks like over the y-axis. That means you have a point on the left side, it's going to reflect over to the right, or you can have some point on the right side reflecting to the left. And that's going to be over the y-axis. So when you're reflecting over the y-axis, you're making a horizontal shift, a horizontal change. So from left to right, that's horizontal, which means our x coordinate is going to change. If you're on the negative side, it's going to come to the positive. If you're on the positive side already, it's going to go to the negative. So that means you're going to actually have opposite of whatever x was. But the y, you're not going up or down anywhere. So you're just going to keep the same y. Nothing's going to change. So again, that means you're going to have the opposite x, opposite of x. All right, and again, opposite means two numbers that are the same distance from zero. To confirm that you did the reflection correctly, your original point and your final point should both be the same distance from the line of reflection, which would be your axes, which was your 0 point. All right, so let's do the first example. Just a quick vocabulary check or understanding check. If these two are reflections. They are going to be congruent, by the way. When you reflect a figure, they remain congruent. Same size, same shape. Now, they're in a different position, but they will still be the same size and shape. All right, so that's one example. And the other example. And it says, are the figures a reflection of each other? Now, this is very important to just make sure that you do this neatly because they are supposed to be congruent figures. I have graph paper, which makes it a lot easier to make sure these figures are congruent. But I'm going to use this transparent paper just to show you that I'm going to confirm whether or not they are reflections. So I do that. It's probably going to be a little wet. And now if I were to flip this over, it looks like it lands perfectly. So that is a reflection. And on this one, again, I take this paper and I flip it. And you can tell it's not lining up on this other figure here. So I can say it's not. I tried flipping it, mirror image, and it's not lining up. Another thing you can tell also is these are corresponding points. Are they the same distance from zero? This looks like it's 1 unit. This looks like it's 2 units. So again, these corresponding points are not the same distance from the line of reflection, so no. One way we could confirm also is this one. The bottom one could have been facing down or the top one could have been facing in, but clearly they're not, so no. Corresponding points. Are not the same distance from the line of reflection. You could have also said something like, no, the top triangle needs to be facing down, or the bottom one needs to be facing down. Yeah, so either way. And the first one, yes, because they are mirror image. Now, if you don't have that clear paper, another way you can do that is you just pick up your paper and just imagine that you're folding it on this line here, this black line. I don't know if you can see it, but if you were to fold it, you can imagine that they're lining up and see if they would have been symmetrical that way. All right, so next example. Says you are given these coordinates, A, B, and C. Reflect over the x-axis and give the new coordinates. -1, 3, -1, 1, and C is 2, 2. So there we go. I'm going to reflect this over the x-axis. So that means I'm going to take this point down. Remember, in order for it to be a reflection, every vertex needs to be same distance from the line of reflection. So if this C is 2 units up, in the mirror, it's going to also appear 2 units on the other side. C prime, my new C. B is 1 unit away from the mirror, so it's also going to be 1 unit on the other side. And A is 1, 2, 3 units away from the line of reflection. So I'm going to go 1, 2, 3 units on the other side. And so now I have my new triangle. Now I did this on the graph, and to get the new coordinates, now I just label them. A prime is -1, 3. Sorry, -1, -3. B prime is now going to be -1, -1. And C prime is going to be 2, -2. Now, had I not had this graph, I could still get these new points from these. How? Because of what I said over here. We were doing a reflection over the x-axis. That means I'm only changing my y to its opposite. Simple. Reflecting over the x-axis, all I'm going to do is take my y coordinates and make them opposite. Did that happen? -1, opposite of 3, -3. Take the same point, only change my y coordinate to its opposite. Keep the same point, take my y coordinate to its opposite, and it did work. So all of my y's were opposite. There you go. 2 ways to do that. Shortcut, or if you need to be visual, just you can put it on the graph. And the last one. So I have I have A, B, C. So the instructions are to reflect, this time over the y-axis. Triangle ABC over the y-axis. Now, I don't have the coordinates, but I can get them from the graph. And I'm going to do the shortcut on this one. A originally is 1, 2, 3, 4, 5, -5, 3. And B is originally -3, -3, +3. And C is originally -2, 1. So those are my original coordinates. And I'm going to just apply the rule. If I'm going to cross the y-axis, then that means I'm making a horizontal change. So my horizontal coordinate changes. My x's are just going to become opposites. So my x is going to be opposite. If it's -5, now it's +5. Remember, the y is going to stay the same. That's my new A. My new B, again, only my x is going to be opposite. Keep the y the same. And my new C, only my x is going to be opposite. And I'm going to keep the y the same. And those are my new coordinates. And that is my new coordinates for my reflection. Quickly just graphing them, make sure that it's right. So 5, 1, 2, 3, 4, 5, 1, 2, 3. My new A, 3, 3. My new B and C, 2, 1. Oops, right here. Ignore that one. So there you go. This is the same triangle. Are they the same distance from the line? 1, 2, yes, 1, 2. 1, 2, 3, 1, 2, 3. A is 1, 2, 3, 4, 5 from the mirror or fold. 1, 2, 3, 4, 5 from the mirror. So it works. So these are the same rules that will work for any reflection. You just got to remember what's being changed and which one becomes opposite. There you go. So reflecting over x and y axis